Okay, we'll continue now. So let me give you a simple example that gives us a small drawback to binomial. Let's take a simple little example. So let's suppose I have something like we asked, let's say we asked 20 people to vote, doesn't matter on what, and the probability that an individual person would vote positively, we'll say, is 0.45. So whatever we're asking people to vote on, they're not quite past the 50% mark. Now, that doesn't mean that it's definitely going to lose, right? Because if somebody has a 45% chance of voting in favour of it, doesn't mean they definitely won't, right? 45% is still pretty good. It's not as good as 50, 55 or 60, but there's still a chance that we could have a positive outcome. If 20 people vote, how many people would need to vote yes? Let's say this is a yes or no vote. How many people would have to vote yes for the vote to succeed? No. Sorry. Just to be clear, you're in the West, democracy, majority, 20 people vote in. 11, yes. 11 or more people would have to cast yes. Right? Sorry, what? Is democracy confusing you? What's the 20 people, 11 would be yes. Okay. But of course, not only 11. If 12 people vote yes, then that's a success. Or we won't count 10 because that's a tie. Okay. Or more. So, for the vote to pass, we need to have 11 or more vote yes. Now you realise the small problem here, yeah?
Can somebody is like, I don't want to vote?
Oh, we won't consider that possibility. In fact, we could consider that as like, if somebody doesn't vote, that's kind of like voting no. So we won't consider that, but we could factor it in. Like you might say, why is this not quite 0.5? Well, maybe because a couple of people don't know and they just leave their vote blank, you know, which will count as a no. Yeah. Most times when you have a vote for a yes-no motion and the person doesn't vote, it's as if they voted no. Because the rule is 11 people have to vote yes, and if you don't vote, then it's as if you voted no for the calculation purpose. Yeah. Anyways, 11 or more. So that is 11 or 12 or 13, 14, 15, 16, 17, 18, 19, 20. So it'll take us a bit of a while to do this on the calculator. So I'm going to switch to Excel to show you it here. So we'll do, what do we say? Can you see? 11? Will I zoom in a bit more? It's okay? And then the next one we have to consider is 12 all the way up until 20. Okay? If there's more than 20 yeses, then we have corruption, because there's only 20 people voting, right?
Corruption.
Yeah.
How much?
Yeah. In fact, you could even say if there were 20 votes, you might have corruption, you know, because not everybody will vote, you know. Yeah. Yeah. Anyways, 11. So what's the formula here? It's 20 C11. So I think I had it here a moment ago. The function is for C on Excel. Okay. 20 C11 times probability of a yes. 0.45 power 11 times 0.55 power 9, or rather 20 minus the 11. So you could actually do that on your calculator and you should get about 12% chance. Does this mean there's a 12% chance the motion will pass? No, just that 11 people will vote for it. Will this next number be higher or lower?
Higher.
Lower.
Because we have
Yeah, because you're asking for a more unlikely thing to happen. You're asking for more than 11 people to vote yes. You're asking for 12 people to vote yes. And the next one here, higher or lower? Now, you can kind of guess, once we get to this stage, this should be pretty close to 0. You know, that's the same as saying you flip a coin 20 times and everyone is heads. You know, so let's see what happens, how quickly it disappears. Okay, so we're already at 1%, less than 1%. Now we're into 10 to the minus 5 now at this stage. 10 to the minus 6. 10 to the minus 7. So the total here is 0.25. So it's not too bad. We've got a 25% chance that the motion will pass. But that means a 75% chance that the motion will fail then. Okay. Now, you can see the problem here. We can't be doing each individual scenario and adding them all up. So the second type of problem we're looking at today is when we have a large number of possibilities to consider. And what's quite convenient, in the formula book, there have been tables calculated with the answers already to certain problems. Now, I have it here. You can open it up in a minute on your phone. I had it here a second ago. Here it is here. This is on the page that's marked 10 of 16. Let me just zoom in. Now, this is how these tables work, and I'll do some examples. This table here is for when you have 5 trials. Yes? N equals 5. Can you see that there? Up the top is the probability you're looking for. So, for my question, what was the probability? 0.45. And then the numbers here is for how many successes you want or less. So, for example, this 2 here means you get 2 successes or less, which is like saying 2 successes or 1 success or no, 0. Okay. Now this becomes very useful in the bigger table. So for example here, 30. Let's say you flip a coin 30 times. What's the probability we're looking at here? 0.5. And suppose my question is, what is the probability that you get heads 10 or fewer times? So, you will go down to 10, go across to 0.5, and here it is here. How did they get that number? What they did was they looked at 0 successes, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, plus 8, plus 9, plus 10. They've done all the calculations for you already. Okay? The word for this in maths is called cumulative, meaning adding up. These tables here have done all the calculations for you. Yeah? Yeah, so that's what we'll do in a moment. So I'm going to do 4 examples here of using the tables, but of course it'd be helpful if you open the tables up on your phone so you can practice reading it as well. Because I'm going to switch back to the laptop now. So it's Appendix C formula book on Moodle. So we'll keep everything for the context for the story about voting. Okay, so we'll have 8 people vote, and each person has P equal to 0.1 for voting yes. Can you see that? Oh, have you got the form book open? Yeah. Got it?
Where?
It's just under resources, books and resources near the bottom of the page. It's like the second link, Appendix C formula book, something like that. Do you have it open? Do you all have it open? I can continue?
It's on Google.
Yeah, that's where I opened my one.
Just a moment.
Maths for Science.
Okay.
Appendix.
You have it open? The same? Yeah, that's fine, yeah.
So,
Guys, can I do an example now? Do you have this open? Ah, come on. What's wrong with you guys? Have you got it open? You have the form book open? And scroll down to page, it's marked page 10 of 16. It looks like this at the top. Binomial cumulative distribution function. Yeah, it's loading now. See it? Oh, come on, what's taking so long? No, it's just. Is it there yet? Oh, whatever. It doesn't matter. Do you have the formula book open?
no.
Ah, what's taking so long? What's wrong with you guys? Come on, come here. Let me have a look. Yes, you are Maths for Science. That's what you're studying. Appendix C formula book. It's literally in front of your face. Do you all have it open now? Yes? Okay. So, let's have a look at this example. 8 people vote, and each person has a probability of 0.1 for voting yes. So if you pick a person at random, how likely is it that they'll vote yes? 0.1. Okay. And my question is, what is the probability that 2 or fewer vote yes? Now this is really nice because this is exactly what the formula book is designed for. These or fewer problems. Guys, come on. Now, what table do we need to go to? We need to go n equals 8, which looks like that's the 4th table, yeah?
Yes.
Which column do we go to? It looks like it's the 2nd column, isn't it?
Yeah.
And what is our x here? It's 2.
Yeah.
So that is 0.9619. Remember, these tables are designed for or fewer. Okay, now as David, you were asking me what do we do if it was the other way around, if it was or more. So we'll look at that in the next example. Just to make sure you've got this, I'll just change the question now slightly. Suppose I had okay, so here's my question. 12 people this time are voting, but it's still the same probability, 0.1. What is the probability that 3 or fewer people vote yes? Yeah, 9744. Yeah. Okay. Are we,
What was the question? 2 or 2?
which one? The one I just asked or the original?
The one you just asked.
Oh, it was 3 or fewer in a group of 12.
Okay.
Yes, can I do another example?
So
Are we okay with the tables? Yeah, okay, so we'll make it a little bit harder now. Example 2. I'll keep it the same. 8 people, and then the probability of voting yes is 0.1. But this time, I'm going to ask for the probability that 3 or more vote yes. This is where the not formula comes in helpful again. This is equal to 1 minus the probability of not 3 or more. Well, what is not, firstly, let's translate. What is not 3 or more? What is the meaning of not 3 or more? 2 or fewer. Yeah. Wait, hang on, what's the grammar here? Fewer or less? It's countable, isn't it? So, fewer, yeah. I think it's fewer, not less. Because you can count the votes, it's fewer. Yeah. Really? Okay, fine. Now, in fact, I think we have this answer from the previous part, don't we?
Yeah.
It's 0.9619, wasn't it?
Yeah.
Yeah, so that's 0. Okay. Right, now, that's okay. Write that one down. Get a little bit harder now. Did you write that down? You have that, guys? Okay, let's look at the next example. Example 3. Let's change it up a little bit. Let's say 10 people vote. This time the probability that they vote yes is 0.8. Yeah, I see, yes. And this time we'll say I want the probability of 2 or more vote yes. Now you see straight away what the problem is the moment I wrote down the value of p. What's the problem here? There's no 0.8. What's the biggest value here? 0.5. But this can be fixed by changing your perspective. Rather than looking at people voting yes, but yeah, we look at people voting no. So we need to change this into a statement about voting no rather than voting yes. So 2 or more people voting yes. Okay, well firstly, if 2 people vote yes, how many then must have voted no? 8. And if more people vote yes, then is it 8 or fewer vote no. Now, before you look up the formula book, let me get the info off you. What's the n here this time? 10. What's the p? 0.2, because we're looking at the no's. And what's the x here? 8. So now we can get that. Let's see. Yeah, it's so close to 1 that they round it off to 1, don't they? Okay. You got that? Is that okay? Now the last one. Okay. Yeah, what's wrong?
Is this the one final answer for the first, for the main question?
Which one?
Since we're looking, we use 0.
Yeah, that's the answer. 1.0. Because these two are the same statement. All I've done is phrased it in terms of no votes rather than yes votes. But it's the exact same statement. Well, okay, it's the same value. It's the same meaning. You know. Can I do the next examples? Okay, now I'll let you try this one by yourself before I do it. Let's see if you can figure this out. So, example 4. Again, we'll go back to 8 people. And the probability of a vote yes, we'll make it 0.8 for a yes vote for any individual. And this time I want the probability that 3 or fewer vote yes. No, we're at 8 people this time. 8 people.
So which means 4 or more. Okay, 2
There is no 0.8.
No, we take
Yeah, exactly. Yeah.
So we trade it for something else.
It's gonna be no.
Yeah, you'll have to convert it to no's first. I'll have to calculate it. That sounds wrong. It's very likely that people are voting yes. So I'd expect it to be unlikely that only 3 vote yes or fewer. So I'm thinking the answer should be a small number, not a big number. I think. I'm not sure. I'll have to calculate it. Will we have a look at it? You look like you're struggling.
Just plus them. No, just use 0, 1, 2.
No.
You can just plus them.
Okay, but if I changed it from 8 to 30 and 3 to 10, that'll take too long. Let's have a look. Let's have a look. Pay careful attention, please. Now, guys, pay careful attention. Now, has it? Pay careful attention because I'm about to do it. This is the hardest example, and the reason it's the hardest example is because it contains 2 complications. The first complication is the 0.8. None of the tables have 0.8 in it. So we'll have to convert from yeses to nos. Step 1. So, 3 people voting yes would be how many people voting no? 5. If less people vote yes, then what is happening to the more? Yeah. So you're basically saying 5 or more
Voted no.
vote no. Okay? But here's the second problem. Our tables aren't designed for or more questions. They're designed for or fewer questions. So we convert this one into 1 minus the probability of not 5 or more no's. Well, what does it mean to say not 5 or more?
The same as more.
4 or fewer no's. So we have to go to our tables. We need to go to table n equals 8, p equals 0.2, and x equals 4.
How did you get to 4?
1 sec. 1 minus, what's this number here, please? I'll look at actually. 8, no, I got it here, let me see. 8 to 9, 8, 96. So what's that? 0, 0, 0, 1, 0, 4, like this?
Yeah.
Okay.
Teacher, I don't understand why you said four or fewer.
Yeah, you did understand 20 minutes ago, but it's getting quite complicated now. So, let's just focus in on this one here. Listen, no, I'm going to explain it, so listen. 5 or more. Well, what is that saying? That's saying 5 people vote yes, 6 people vote yes, 7 people vote yes, or 8 people vote yes. So, 5, 6, 7, 8. Not having this. I don't have this. So if I don't have 8, 7, 6, or 5 people voting yes, then how many do I have voting yes?
4.
The rest. 4, 3, 2, 1, 0. Or, in other words, 4 or fewer. Okay. See, there's a couple of ideas you need to have in your head, and they're starting to add up now. But this is the hardest example because it puts all the ideas together into one. Yeah?
I didn't get the more thing.
5 or more.
Yeah.
Okay, well, if 3 people, you have 8 people,
Yeah.
3 of them vote yes. So how many voted no?
Why?
Yeah.
No, I mean you said we have to change more. Like,
No, what are we changing when we did the first thing here? What was the purpose here? It wasn't to change the fewer or more.
Have 0.8.
It was to change the yes to no.
yeah, I get
Yeah.
that one.
Yeah.
But I mean you said we have to make it 4 or fewer.
Oh, here?
Yeah.
Oh, yeah, because our tables only work for fewer, not more. All these tables,
It's add up, right?
it's add up fewers, not more. So I can't use the tables if my question was 5 or more.
And then we just
I have to convert it into a question about or less or fewer.
Then how did you make it fewer?
Oh, here?
Yeah.
Oh, that's what I was just saying.
No, I mean how did you get like 1 minus 3, 4? From where did you get the 4?
Here to here.
Yeah.
Oh, I just said it to her 1 minute ago. Okay, one more time, right? And I'm not repeating this. Okay? Not 5 or more. Okay, so let's look at 5 or more. 5 or more means 5 voted yes, or 6, or 7, or 8. That's the meaning of 5 or more. Yes?
But we cannot use this.
But we can't use this. So what's the opposite of having 5 or more?
4, 3, 2.
Yeah? 4 or fewer. Yeah?
But we said 1 minus first, right?
Yeah, I'm using, what rule am I using here? This is the not rule.
1 minus.
Oh, then that's
The not rule, yeah. Yeah. It's difficult, I mean, it's not difficult for calculation. It's difficult for converting.
Yeah.
But like I said, this is the most difficult example because you have to do 2 corrections. In the exam, it's usually 1 correction.
Is it 1 mark?
No. This one here,
maybe 3 or
no, I'd say,
3.
I'm about to say it, so just be quiet. Okay. I would say it's 3 marks. Okay, because 1 mark for the first correction, the second mark for the second correction, and then the third mark for the tables. The final answer, yeah. Yeah.
Okay. And then
Wait a second, how's this? Sorry, go.
You could finish with him.
Yeah.
So here you made 1 minus the.
Yeah.
So it doesn't affect these. We just when we go to the table we get the
Yeah.
line.
Yeah, which is that number.
Yeah, and then we
1 minus, yeah. And we got that. Okay.
So just a question.
Yeah.
Could we say that if it's not 5 or more, no? Is it like 5 or more, yes? If it's not before, no.
Okay.
No.
No? We cannot. It's
What are you asking me?
that's a point that we circled.
I can't hear Nikita's likely strange question. What is your? What are you asking me?
The 1 minus probability not 5 or
1 minus the probability of not 5 or more
No.
knows.
Is it the same as 5 or more yes?
No.
No. I don't think so.
Minus 1 minus
Not
5 or more yes.
I was starting to
Okay, wait.
What's the trial?
Guys, don't look, it's just confusing.
Yeah.
Wait. If it's not 5 or more no's, it means it's 5 or more yeses.
If 5 or more no.
Is it works like this?
use more in our table.
No, shh, be quiet, please. Nikita just wants to know, are these two the same? Let's just check. Okay, so look. This one here is the not in it. So I can remove the 1 minus and the not, and I can say that this confidently I can say is the same as the probability of 5 or more. Are we talking no's for both?
No, you said yes.
Yeah, yes, but
This
we
is
just-
yes.
We
But it's not-
stay 1 minus. Dash, it's not your question.
Shh, please. 5 or more no's. 5 or more, yeah. No. I don't think they're the same.
Because not is not related to the no. It's more related to the...
The not is more related to the number rather than the question. Oh, I see. So I understand your question now. Yeah. The not negation is for the number, not the response to the question. Yeah, okay. No, that is a sensible enough question. Yeah, it just took a while for me to understand what you're asking me. Yeah. The question is, when you use the not here, is that not being applied to the response, to the whole statement, or what exactly? That not is being applied to the number, really, not to the response that the person is given. So you're flipping the numbers around, not this response. Yeah. Nikita, please. Dasha, you're also not helping. Right. These questions are quite short to do because they only require the formula book. So you should be able to do all of the questions. You can get a start on them now. Oh. Do you know how to read? That's all that's needed for this.